If you look at these geometric shapes multiplying across the screen, you are looking at what it feels like to scale modern software. Every new service you spin up generates a massive wave of telemetry. That compounding pressure isn't an accident. The financial models of the dominant observability vendors are built specifically to capitalize on that exact momentum. Look at the standard line items on your monthly invoice. You are billed for the total volume of data ingested, the number of hosts monitored, the user seats required to view the dashboards, and how long you keep any of it. The core mechanical problem here is that every single one of those metrics operates on a one-way ratchet. As you add a new service or deploy another container, those numbers only move in one direction. The better you get at scaling your infrastructure, the harder you are punished financially. You find yourself paying a tax on the raw volume of your exhaust, rather than the actual insight you extract from it. This diagram maps out the standard telemetry pipeline. Over here on the left, we have the origin point, the services, containers, and traces generating the raw signals inside your environment. Follow this arrow as the data leaves your infrastructure. It travels across the internet to reach an external vendor for processing and storage. The first financial leak happens right here at the edge of your network. The moment those bytes cross the boundary, you incur external network egress charges. After crossing that expensive threshold, the data flows into the vendor's proprietary environment to be parsed and stored. Here is where the heavy tax is applied. Notice the compounding dollar signs inside the database. Vendors apply massive premiums for indexing this incoming data and enforce steep surcharges for every week or month you need to keep it. The mechanical reality of this architecture is simple. The instant your telemetry data leaves your own network, you surrender financial control to egress tolls and indexing premiums. To stop the financial bleeding, engineering teams turn to a desperate default tactic: sampling and filtering. Instead of sending complete records, you drop data. Watch this filter delete half the incoming blocks, leaving holes. This shrinks the payload, bypassing heavy triggers to lower your bill. But zooming in, the trade-off is obvious. You are intentionally blinding your operational history. When you treat telemetry data like heavy cargo thrown overboard, you solve a budget discrepancy by creating a severe liability. Consider a strict compliance audit or post-breach investigation. This sweeping digital scan represents the deep, forensic level of scrutiny your systems will inevitably undergo. In those high-stakes moments, auditors and security teams have a strict, non-negotiable requirement. They demand a completely intact historical record to reconstruct exactly what happened. Compare that strict demand against an infrastructure that relies on sampling. You are trying to provide a perfect timeline using data that has been heavily summarized and arbitrarily discarded. If an anomalous event occurs in a dropped packet, there is no way to retrieve it. Try explaining to a federal regulator that the evidence they legally require was deleted to hit a quarterly cloud budget. This is the impossible choice standard observability models force upon you. You either drop essential operational data to survive the month, or you retain the full picture and bankrupt the engineering department. There is a third path. We have to reject the premise that you must trade data fidelity for financial survival. The solution requires stepping back and applying a different mechanical function: lossless compression, executed directly at the source. Let's alter the architecture flow. We add a source compression node next to the services. Watch this massive block of raw data enter the node. It compresses into a tiny, dense package before it reaches your network edge. This is a critical distinction from the filtering tactic we examined earlier. Lossless compression means exactly what it says. Not a single piece of information is discarded, and nothing is summarized. Every individual log, every single trace, and every metric is retained in full. By intervening inside your own walls, you sever the mathematical link between raw operational exhaust and external network egress costs. This chart illustrates the shift. The left shows raw data at 100%. On the right, source compression reduces the same data to just 3 to 5%, an 18x to 30x reduction. Yet this tiny footprint retains 100% data fidelity, 0 events dropped. Think back to the leaky funnel of data sampling. To achieve a 30 times reduction in cost through filtering, you would have to throw away roughly 96% of your system's memory. When you alter the sheer physical weight of the data itself, you achieve a massive amount of infrastructure leverage. It is a vastly superior engineering strategy to artificially restricting the flow of critical information. With the payload size solved, we can dismantle the second major financial leak: vendor indexing and retention surcharges. Storing massive amounts of raw text locally used to be cost prohibitive, but when your entire telemetry footprint is suddenly 30 times smaller, housing that data on your own infrastructure becomes incredibly cheap. Track that compressed data again. Instead of sending it out, it flows directly into your dedicated cloud storage bucket. Watch the cost metric plummet as it settles in your environment, replacing premium enterprise indexing fees with standard, low-cost object storage. Because you own the storage, the retention surcharge disappears. You are no longer paying a penalty to a third party just to hold on to the historical data you are legally required to keep. You have reclaimed sovereignty over your own infrastructure. By keeping the heavily compressed data in-house, you completely neutralize the most aggressive billing vectors of the observability tax. Now, return to the scenario of a high-stakes security breach or regulatory audit. When investigators demand the logs from 6 months ago, you have them. Because the data was compressed losslessly and stored cheaply, the entire unedited operational history is sitting in your cloud, ready for forensic review. This system is audit-grade by construction. There is no anxiety about whether an important packet was discarded by a sampling filter because nothing was ever summarized away. Your engineering teams no longer have to play a guessing game about which logs might be important in the future. The new economics make it easy to keep absolutely everything. Let's look at the final numbers. By shrinking the payload at the source and storing it locally, total observability costs drop by roughly 90%. At the exact same time, the operational impact is a perfect record, with 0 events dropped. Lower cost, complete data fidelity, and strict compliance have finally stopped being a trade-off. If you want to analyze your own specific traffic patterns and see exactly how much you can compress, you can view the technical demo at sasquatchlabs.io. Time to end the cycle of paying for the raw weight of telemetry data and start architecting your infrastructure for actual value.